Hello everyone, this is Dr. A classes for BTech students. This lesson titled Earth's Internal Forces is the eighth topic in engineering geology. It explores how forces from within the Earth, such as tectonic activity and mantle convection, shape the planet by causing movements in the crust, leading to formation of mountains, earthquakes, and volcanic activity. It is designed to provide BTech civil engineering students with essential geological knowledge. Learning objective of the course is recognizing the internal forces within the Earth that shape its surface features, explaining how heat from the Earth's interior and mantle convection derive these forces, identifying how these forces contribute to the formation of mountains, rift valleys, plateaus, and other landforms, analyzing the role of endogenetic forces in plate movement and their interactions at different boundary types, convergent, divergent, and transform boundaries, assessing the impact of earthquakes and volcanic eruptions on human settlements, infrastructure, and ecosystems. The dynamic Earth. The continuous erosion and leveling of Earth's surface is counteracted by internal forces. These forces originate from the Earth's interior and lead to various geological activities, including mountain building, earthquakes, and volcanic eruptions. Internal or endogenetic forces. Internal forces, also known as endogenetic forces, are geological forces that originate within the Earth. They are responsible for creating various landforms through processes such as tectonic movement, volcanic activities, and seismic events. Earth's movements. The Earth has undergone significant changes in the distribution of continents and oceans. Movements within the Earth's crust have played a crucial role in shaping the planet's surface. These internal movements contribute to the formation of mountains, volcanoes, rift valleys, and oceanic trenches, while also leading to land subsidence. Types of Earth's movement. Plate tectonics. Plates move due to mantle convection. Volcanic activity. Magma rises, forming new landforms. Earthquakes. Sudden release of stress along faults. Isostatic rebound. Crust adjusts after weight changes. Plate tectonics. Earth's lithosphere and tectonic plates. The Earth's outer shell, called the lithosphere, is divided into large sections known as tectonic plates. These plates are rigid and float on the underlying asthenosphere, a semi-solid layer composed of molten rock. The lithosphere includes both continental and oceanic plates, which interact with each other at different plate boundaries. Plate movements and mantle convection. The movement of tectonic plates is driven by mantle convection, a process caused by heat from the Earth's core. Hot magma rises towards the surface at mid-oceanic ridges, cools, and then sinks back into the mantle, creating a cycle of convection currents. These currents act as force that pushes and pulls the plates, causing them to drift over time. Formation of landforms due to plate movements. Over millions of years, plate movements have shaped continents, oceanic basins, and mountain ranges. Earthquakes, volcanic eruptions, and the gradual drifting of continents are all result of these continuous movements. The interaction between plates result in different boundary types, convergent, divergent, and transform boundaries. Convergent boundaries. At convergent boundaries, two tectonic plates collide due to movement driven by mantle convection. This interaction results in either subduction, one plate sinking below another, or continental collision, both plates pushing upward to form mountains. Types of convergent boundaries and their effect. Oceanic continental convergence. The denser oceanic plate subducts beneath the less dense continental plate. The process creates subduction zone leading to volcanic activity and earthquake. Examples are the Andes Mountains in South America, formed by subduction of the Nazca Plate beneath the South American Plate. Oceanic convergence. When two oceanic plates collide, one subducts, forming deep ocean trenches and volcanic islands arc. Example, Mariana Trench and Japanese archipelago. Continental convergence. When two continent plates collide, they are pushed upward, forming massive mountain ranges. Example, the Himalayan formed by the collision of Indian plate and the Eurasian plate. Divergent boundaries. At divergent boundaries, two tectonic plates move away from each other, allowing magma to rise and form new crust. These boundaries are associated with volcanic activity, earthquakes, and the formation of new landforms. Types of divergent boundaries and their effects. Continental divergence. When continents begin to split apart, it forms a rift valley. Over time, this rift can widen, leading to formation of new oceans. Example, the East African Rift Valley, where the African continent is slowly breaking apart. Oceanic divergence. When two oceanic plates move apart, magma rises to form mid-oceanic ridges, creating new oceanic crust. Example, the Mid-Atlantic Ridge, which is expanding and pushing the Americas and Europe, Africa further apart. Transform boundaries. At transform boundaries, two plates slide past each other horizontally without creating or destroying crust. This movement causes intense friction, which results in earthquakes. Effects of transform boundaries. Transform boundaries do not form mountains or volcanoes but cause frequent and powerful earthquakes. The San Andreas Fault in California is a famous example of transform boundary between the Pacific Plate and the North American Plate. These boundaries also exist at the mid-oceanic ridges where they offset sections of divergent boundaries. Volcanic activity. Volcanic eruptions are one of the most powerful natural processes on Earth. They occur when magma, which forms beneath the Earth's surface, rises due to pressure from the Earth's mantle and is expelled as lava, ash, and gases. This process significantly alters the landscape and atmosphere, shaping new landforms while also affecting climate and ecosystem. Causes of volcanic eruptions. The Earth's interior consists of molten rock magma that is constantly in motion due to heat from the core. When pressure builds up, magma forces its way through cracks in the Earth's crust and erupts at the surface. The erupted magma is called lava, which cools and solidifies into new rock. Landforms created by volcanic activity. Volcanic eruptions reshape the Earth's surface, forming new landforms. Volcanic islands. When lava cools and accumulates in oceanic regions, it creates islands. Examples, Hawaiian Island and Iceland, etc. Lava plateaus formed when large amounts of lava flow and solidify over extensive areas. Example, Deccan Plateau, India, Columbia River Basalt Group, USA. Calderas, a large crater-like depression that forms when a volcano collapses into an emptied magma chamber. Volcanic activity and plate boundaries. 80% of the world's volcanoes are located at tectonic plate boundaries. The Pacific Ring of Fire is the most active volcano region, while multiple subduction zones cause frequent eruptions. Effect of volcanic eruptions. Short-term effects are ash clouds block sunlight, affecting temperatures. Lava flows destroys landscape, buildings, and vegetation. Toxic gas, sulfur dioxide, for example, can be harmful to human health. Long-term effects are climate change. Large eruptions releases sulfur aerosols which reflects sunlight and cause global cooling. Example Mount Pinatubo, 1991. New land formation. Over time, lava solidifies to create fertile soils and new lands, new islands. Oceanic changes, underwater eruptions, alters marine ecosystems. Earthquakes. Earthquakes are natural geological events caused by sudden release of accumulated stress along faults in the Earth's crust. These stress accumulations result from the continuous movement of tectonic plates which exert immense pressure on the Earth's lithosphere. Earthquakes are caused by sudden release of stress accumulated along faults in the Earth's crust. Most earthquakes occur at plate boundaries due to tectonic movements. The magnitude of an earthquake is measured using the Richter or moment magnitude scale. Richter scale measures the amplitude of seismic waves. Moment magnitude scale provides a more accurate measurement of energy release by considering fault displacement and rock properties. Earthquake can trigger tsunami, landslides, and structural damages. Isostatic adjustment. Isostatic adjustment refers to the vertical movement of Earth's crust in response to changes in surface weight. This process is driven by the principle of isostasy, which states that the lithosphere maintains equilibrium by rising or sinking relative to the denser, more fluid asthenosphere beneath it. This occurs when the Earth's crust adjusts after the removal or addition of surface weight. During glacial periods, heavy ice sheets depress the crust. When they melt, the crust slowly rises again. This process affects sea level, coastal landscapes, and regional geology. Isostatic adjustment can cause minor seismic activity and shifts in land elevation. Self-assessment questions. At the end of the presentation, these are self-assessment questions. Go through each question carefully. Answer these questions based on understanding of the topic. Review any concept you are unsure about. The questions are: define endogenetic forces. Explain the role of mental conviction in driving plate movements. What are the major types of plate boundaries and how do endogenetic forces contribute to their interactions? Describe how earthquakes and volcanic eruptions result from endogenetic processes. How do endogenetic forces shape landforms like mountains, rift valleys, and plateaus? Provide examples. Evaluate the impact of earthquakes and volcanic activity on human settlements and infrastructure. Thank you for joining this lesson on engineering geology today. Hope you found this presentation informative. Don't forget to like and subscribe the channel Dr. A Classes for more engaging lessons on core subjects of civil engineering. Thanks.